Hello, welcome to Lessons in Logic number 37, a re-recording. In fact, I think it's a third recording now. I noticed that the last one did not work out properly. The Zoom software didn't quite work, or maybe it was too much for my home laptop to handle. Anyway, I'm redoing it. And in this video, all we wanted to do was some basic practice with abbreviated truth tables using that nifty argument from Socrates. So I believe we already went over this argument, maybe, I don't know, a few videos back. Let's look at it briefly and move to the abbreviated truth table. So the argument, just reading it in pretty straightforward, ordinary English, goes something like this. Either there is life after death or there is not. If there is not, then death is just the end of experience. If death is the end of experience, then there's no suffering after death. And if there's no suffering after death, then there's no point in fearing death. But if there is life after death, then we need to be good no matter what. Therefore, either we need to be good no matter what, or there's no point in fearing death anyway. And either way, there's no point committing some injustice to save our lives. Now, you can identify the atomic propositions or the simple propositions in this argument as follows. So the simple propositions are the propositions not made of any others. Note how the first one, there's life after death. Note how our first premise, either there is life after death or there is not, contains that atomic proposition plus its denial. So it's not an atomic proposition. And in fact, the second part of it reads, there is not life after death. That's not an atomic proposition either. It's a negation. So hoping the color coding works for some of you. Either there is life after death or there is not is either L or not L. And not L is not an atomic proposition. And either L or not L is not an atomic proposition. Anyway, let me get back on track. L is there is life after death. That's one of the atomic propositions. We'll symbolize it with L below. E is death is the end of experience. S is there is suffering after death. F is there is a point in fearing death anyway. G is we need to be good no matter what. I is there is a point committing some injustice to save our own lives. Now, Socrates does not say that there is a point committing some injustice to save our own lives. He says there is not. So his conclusion is not going to be that atomic proposition, but the compound proposition that is a denial of that atomic proposition. All right. So here's how we symbolize the argument. If you need to, I strongly recommend you pause the video and read the argument again before I scroll down here. Just a moment. My screen is not arranged optimally. I recommend you, if necessary, pause the video, read the argument again, pause the video, look again over the symbolization system, and then look at how we symbolize it. Maybe try doing it for yourself if that's useful exercise. So using these atomic propositions, this is what we get. And go back and watch previous videos if you don't know the symbolism, but the wedge means or, the tilde means not, the horseshoe means if then, with the if clause to the left and the then clause to the right. So the symbolized argument is either L or not L. If not L, then E. If E, then not S. If not S, then not F. If L, then G, either G or not F. And then we have this unstated premise. It's not stated in the original argument, but it's strongly implied. The unstated premise is if either G or not F, then not I. And the conclusion is therefore not I. Now, let's see. Note how that unstated premise naturally follows. Either we need to be good no matter what, or there's no point fearing death anyway. And either way, there's no point committing some injustice to save our own lives. That motion from either this or that, and either way, final conclusion follows. That implies that there's an unstated premise that if either X or Y, then our final conclusion follows. If either X or Y, then Z. If either of these two, what do we call them, disjuncts? If either of these two disjuncts in statement number 6 here is the case, then the final conclusion follows. There is indeed no point committing some injustice to save our own lives. All right. I think there's something I left out here. Yes, I left out this. Our subconclusion is therefore either G or not F. Therefore, either we need to be good no matter what, or it's not the case that there's any point in fearing death anyway. So let's label it as a subconclusion as we formulate the argument symbolically here. So now just reading the symbols, not just interpreting them, saying either or for the wedge and if then for the horseshoe. Let's just read the symbols. The argument is L wedge tilde L, tilde L horseshoe E, E horseshoe tilde S horseshoe tilde F, L horseshoe G. Therefore, G wedge tilde F, unstated premise, open parenthesis, G wedge tilde F, close parenthesis, horseshoe tilde I. Therefore, final conclusion tilde I. So now let's do an abbreviated truth table on this, and it's got a subconclusion. So we want to do it really in 2 stages. Now, I've done what I can to make this legible. I better reduce the size of my own face here so we can make sure we have everything visualized here. Okay, everything's visualized. I may be able to zoom in slightly. I think this should work nicely. So here are our premises and our conclusion. Now, we're going to do this in 2 stages. And the first stage will go from the first 5 premises to the subconclusion. The next stage will go from the subconclusion and that unstated premise to the final conclusion. So if need be, pause the video right here and right here. If necessary, go back and forth. If you're on a keyboard, if it's YouTube, I think you can push the left button to scroll back 5 seconds, or the right button to scroll forward 5 seconds. So scroll backwards, scroll forwards is needed to compare and contrast, make sure you understand how we got this. In fact, let me just state how we got this, even if I don't need to go over it again. We had this argument in ordinary language. We observed this symbolization system, and I color-coded it, hoping that will help. And then we symbolized the argument here. And now we've taken that symbolic argument and stated over here. Now we can forget what the argument was even about if we want to, because now our only goal is to see if the premises guarantee the conclusion. Oh, and this 3 dot symbol means therefore. So the atomic propositions in the move from the first 5 premises to the subconclusion are L, E, S, F, G. And then in the move from that subconclusion plus our originally unstated, but now stated premise. The atomic propositions there are G, F, and I, and here are the premises. So, abbreviated truth tables. What do we do in an abbreviated truth table? We prove that the argument is valid, or test to see if it's valid. Let's not, well, you probably know whether it's valid if you've been watching this series, but let's not state it in case I didn't say it last time. Let's test the argument for validity. And in order to make an abbreviated truth table work, you test the argument for validity by assuming it's invalid. And if that assumption turns out to make sense, then we can conclude the argument is indeed invalid. But if the assumption that the argument is invalid does not make any sense, then it turns out the argument is valid. And that's how we prove validity. We prove invalidity by showing that the assumption that the argument is invalid does not lead to disaster, and we prove validity if the argument is valid by showing that the assumption of invalidity leads, what did I say? We prove invalidity with an abbreviated truth table by showing that the assumption of invalidity does not lead to disaster. We prove validity by showing that the assumption does lead to disaster. And to make it work, to make the assumption, let me say, we say that the conclusion can be false and the premise is true at the same time. So that means we temporarily assume that the premises are true, conclusion false at the same time. And in terms of full truth tables, we're just going to find a row. There are a lot of rows on this truth table. 1, 2, 3, 4, 5. The full truth table would have 2 to the power 5 rows. What is that? 4 times 4 times 2, 16. 16 times 2, maybe it's only 32 rows. Am I getting confused on the math? Still seems like a lot if you ask me. 2, 4, let's see, 2, 4, 8, 16. I guess it's only 32 rows. It's not all that many. But we're going to assume that one of those 32 rows has true premises and a false conclusion. And we're going to see what that row looks like. But if we can't see what it looks like because trying to lead to disaster, then we know the argument is valid. That's the general idea. So we assume the premises are false. We assume the premises are true and the conclusion false, and we'll make the same temporary assumption over here. But let's not jump ahead yet. Let's not get ahead of ourselves. Working with the first stage of the argument: false conclusion, true premises. Now we just fill in the details. Now I notice that the conclusion is a disjunction. That makes it a lot easier. There are three ways a disjunction can be true. Three ways a horseshoe statement can be true, and then we've got other horseshoe statements in the premises. So we definitely want to start with the disjunction and the conclusion. There's only one way a disjunction can be false. An either-or statement can only be false if both parts of it are false. The either clause has to be false, and the or clause has to be false. Both of them have to be false. So if G wedge tilde F is false, then G is false, and tilde F is false. But if tilde F is false, then F is true. So now we can make very fast headway through the rest of this. G must be false, and F must be true under our assumption of invalidity. If that row of the truth table exists, it's going to look like this. It's going to have G as false. Where else does G turn up? That's the only place G turns up. And F as true. Sorry. There we go. F is true. And keep filling in the details. No more F's and G's, but we certainly don't have to stop here. There is now only one way for L horseshoe G to be true. An if-then clause, if true, when its consequent is false, must have a false antecedent. If it's true that if L then G, then L can't be true when G is false. Oh my goodness. Let me see if I can say that succinctly one more time, more clearly. If it's true that if L then G, and G is not true, then L can't be true. There, I don't know how else to say it more clearly. So now let's fill in the gaps. Now we know that L is false. And actually that tells us a whole lot. I hardly even know, just a moment, I hardly even know where to proceed. If L is false, well, that just tells us everything we want to know. Let's fill in the gaps. And I think there's no problem here with our first premise. Oh, please don't get confused by the color coding. The color coding here was to help us understand where the atomic propositions are found in the original argument. And the color coding here in the Excel document is just to keep track of which premise is which and which conclusion is which. No correspondence of red here to red back there, all right? But I put these boxes around it, which should be sufficient. Let's see, where was I? Well, there's no problem with this first premise. L or tilde L, it's true. If the first disjunctive is false, the second one's still true, so no problem. So let's keep filling in our gaps. Where did we stop? I think we stopped here. This is where we need to go next. We've concluded that L must be false if the argument is indeed valid. And that tells us that tilde L is true. So now there's only one way for this horseshoe statement to be true. If it's true that if not L, then E, and not L is true, then E also has to be true. So now we know E is true. We fill in the gaps. And then we keep going. Behold, if E is true, that tells us tilde S is false and S is true. Because there's only one way for a horseshoe statement, an if-then statement, to be true if its antecedent, its if clause is true. If the if-then statement is true and the if clause is true, then the then statement, the then clause has to be true. So the then clause is tilde S, not S, therefore S must be whoa, hang on, I botched that. Woo. Fixing, there we go. If the if-then clause is true and its antecedent, its if clause is true, then its consequent, its then clause must also be true. Well, now we've got it. If the if-then clause is true and if the if-then statement is true and the if part is true, then the then also has to be true, the then part. E horseshoe tilde S, if E then tilde S. If that's true and E is true, then tilde S must be true. And that tells us that S is false because tilde S means not S. It's true that not S, then S is false. And now we keep on filling in the gaps. And if S is false, now in our next premise that tells us, sorry, I'm watching it again. If S is false, that tells us that tilde S is true. not S is true. And that tells us something, and it's going to tell us everything we ever wanted to know about this argument. If tilde S, then tilde F is our premise. And we now see that the if clause is true. And we're assuming that the premise is true. The if then is true, and the if part is true. That tells us what? That tells us that the then clause has to be true. But the then clause is tilde F, and we already said F is true. So tilde F is now true, but tilde F is a denial of F. So that tells us that F is false. So F is now both true and false, therefore disaster. The assumption of invalidity leads to disaster. So now it's useful to show that the argument is valid. Let's see. Is it a good idea to big? And no, let's not make the font bigger. How else can I emphasize this? Maybe I can do something with the borders. Well, I guess I can do that, but it's not much of an emphasis, is it? I can italicize it and underline it there. That's a slight extra emphasis. If I were doing this in hard copy, of course, I would circle it. That's normally what you do. Draw a circle around it. But I'm not going to do that here because I'm working with Excel. I can't draw a circle in Excel, at least I don't know how. Okay, so explaining that it's invalid. Okay, so sorry, explaining that it's valid. Don't get mixed up. The assumption of invalidity leads to this contradiction. It's sort of like a double negative. The assumption of invalidity leads to a contradiction, which means the assumption of invalidity is false, which means it's actually valid. So under the assumption that the, oh, that's just such fancy language. Let's put this in simple English, shall we? If we assume that the argument is invalid, meaning that the premises can be true and meaning that the premises can be true and the conclusion false at the same time. If we assume that the argument is invalid, we are led unavoidably, inescapably, inevitably to the statement F being both true and false. Which is impossible. So if we assume that the argument is invalid, we're led unavoidably to the conclusion that the statement F is both true and false, which is impossible, therefore the argument is valid. So the assumption of invalidity was a mistake. Yay, good job, Socrates. You have a valid argument. But wait, does he really? Well, he has a valid argument up to the sub-conclusion. But now let's check out the sub-conclusion to the final conclusion. I really am going to go through this a whole lot faster, I think. Assume the premises can be true and the conclusion false at the same time. And noting that there's 3 ways for an either-or statement to be true and 3 ways for an if-then statement to be true, I check the conclusion very conveniently. It's a simple tilde. And that is false, which tells us that the thing negated is true. I is therefore true. And fill in the gaps. And keep going, see what follows. If I is true, then in our second premise here, tilde I must be false. And now that we know that the consequent is false under the assumption that the argument can be invalid, that the consequent is false to this premise, that tells us that the antecedent must be false. If the then clause is false and the if then statement is true, then the then statement must be, then the if statement must be false. If it's true that if X then Y and Y is false, X must also be false. That's the principle here. And if this is false, if an either-or statement is false, both sides of it have to be false. So that tells us now that G is false and not F is false. And if not F is false, that tells us that F is true. And if not F is true, then sorry, if f is true, then tilde f is false. Now, I think I've occasionally seen a student make this mistake. It's an understandable mistake. You fill in all the gaps and you just stop there. Well, you can't just stop there. You got to make sure it all hangs together. So basically, you just want to follow the inferences where they lead you. So where did this inference lead us? It led us here. All the inferences from our assumption of true premises and a false conclusion led us this way. I is true, therefore G wedge tilde F is false, therefore G is false, tilde F is false, therefore F is true, and therefore tilde F over here is false. And where does that leave us? Well, that leads us where this that leads us to the statement to which tilde F is relevant, to which tilde F's falsity is relevant. Tilde F's falsity is relevant to this premise, the original subconclusion, to G wedge tilde F. And we've determined that on our assumption of invalidity, G wedge tilde F is true, but G is false, and tilde F is false. The either or statement is true, but both the either and the or part of it are false, therefore disaster. And if you're thinking this doesn't make sense, well, you might be right. It kind of doesn't make sense. That's what abbreviated truth tables are about. It's finding out exactly what doesn't make sense and therefore shows you what does make sense. If you assume that it's possible for the premises to be true and the conclusion false at the same time, you find out that things don't make sense. A statement is true and false at the same time. The assumption of invalidity leads to disaster. And that tells you that the assumption was false. The argument was valid from the get-go. We were wrong when we assumed it was invalid. It's not possible for the premises to be true and the conclusion false at the same time. So assuming the argument is invalid leads to something that just doesn't make any sense. And that's kind of the point. That means we were never supposed to make that assumption in the first place, except we were, because that's how you do an abbreviated truth table. But it tells us never to do it again. Socrates' argument is valid. I tell you, it's a perfect argument. At least it's not possible for the premises to be true and the conclusion false at the same time. Now, for the extra nerdy logic students, I'm gonna say, well, stop right here. Stop watching if you're not an extra nerdy logic student. But for those who are, I'm gonna do a lot of Control Z and just quickly illustrate a way we could have done that first one. Because I think we could have gone a different direction. I kind of want to experiment with it and make sure it works. Which direction did we go? We went with following G's to L's. So now let's try something different. We go with the assumption of invalidity, and I might not even talk through this. I'll just see what follows. F true, G false. F true. Okay, good, good. So yeah, you can follow the inferences in the opposite direction, and it'll often work out just fine that way. This will tell us S is true, and I think the inferences will just keep on working, going backwards. Oh, good. I see what the problem is. Well, there's no problem here. If L is true, L or tilde L is true. This one's always going to be true. There's no avoiding that. But now if L is true, then we find our contradiction here in a different location. And that, I suppose, is quite enough practice with abbreviated truth tables. If you watch this whole thing, golly, let me know in a comment you actually watched this. Thanks for watching. See you next time.